Hello, in this video, we are going to look at piecewise functions. We're going to start with evaluating them, and then we're going to graph them, and then actually write a piecewise function for a graph. So let's look first at just evaluating piecewise functions. So this is a piecewise function, and you can see why it's called a piecewise function because it's three different pieces in this case. One thing to notice is you will never use more than one piece at a time. So we have this top and middle and bottom piece in this case. And if x is less than 0, then you plug the number in here. If x is in between 0 and 2, you plug in here. And if x is greater than 2, then you plug in here. One thing I highly recommend is to get rid of what you're not using. So if we want to find f of 12, then we got to figure out which function or which piece of the function we're going to use. Because 12 is greater than 2, I'm going to use the bottom. So let's cover up the other two, and you can either use like your finger, a piece of paper, or if you're using like a stylus, just scratch it out. But now that really this x is greater than 2, you already know that, so you can really get rid of that also. So you're really only looking at that piece. If you can narrow it down just to say, okay, well, that means I'm going to do 12 minus 2 squared, then that simplifies the problem, and you'll probably avoid a lot of mistakes. And so that's 10 squared, which is 100. So f of 12 is 100. Notice this is a piecewise function. Let's get rid of these for a moment. Meaning that every input only has one output. So there's no reason to plug it in the other spots because then it would give you more than one output. Okay, so pause the video and try these other two. F of -9, you got to figure out where it is. That's the top function. So let's get rid of the bottom 2 because 9 is less than 0. And now that you don't need that 0 anymore, even you can cover that up with something and just say, I'm going to plug it into 3x. So f of -9 is equal to 3 times -9. So f of -9 is -27. Okay, and then let's look at f of 2. Be careful with your inequality symbol here because 2 is not greater than 2, but it's equal to 2. We're going to use the middle one. So let's cover up the bottom, and let's cover up the top. So you're only looking at the piece you're going to actually use. And f of 2 is just 2 plus 1, which is 3. This can be very confusing even once you think you get it, right? Like once you understand it, you'll come back to like the next question and you'll end up getting confused. You'll want to plug it into different spots. A lot of times where people get confused is they try to plug x in over here and make it work that way. This just tells you where to, this is where to plug in. And this part stuff over here is actually where you actually plug in. Okay, so when we graph, we're going to kind of use the same strategy where we're going to look at this in pieces. So we're going to start just by looking at the top. So let's cover this bottom piece up, and we're only going to look at the top and say, well, x is less than or equal to 2. And let's start there. Okay, so I'm going to make a table, and I'm going to actually move that because I want to put room to write. Maybe I'll just see if I can cover it up with a pen. There we go. So I'm going to make a table for x minus 2 squared minus 3. And then we're going to always include this 2. So I'm going to put that 2 there. Because it is less than or equal to, I have a closed circle on the graph. So I would recommend you go ahead and put a closed circle there as just a reminder. And then you want to pick another x value or 2. Let's choose 1 and 0, just so we can kind of see the shape of the graph. And plug those in. And when I plug in 2, I get 0 squared minus 3. Maybe we should write that out. 2 minus 2 squared minus 3. So that would be -3. When I plug in 1, I get 1 minus 2 squared minus 3. So that'd be negative 1 squared minus 3 is negative 4. And when I plug in 0, I get 0 minus 2 squared. Oh, let's see. I forgot. I squared my negative wrong. 0 minus 2 squared is negative 1. Squared is positive 1. Minus 3 is 2. Negative 2, that is. And then 4 minus 3 is just 1. Okay, that looks better. So these are points on your graph. If you want to go ahead and plot them, you can. I'm going to wait and plot them all at once. And now we're going to look at the next piece, which is the bottom. So the bottom is f of x is equal to x. And here's where you can talk yourself into messing up the graph, is because it's x is greater than 2. And so a lot of people will say, well, x is greater than 2. I'm going to start with 3. But if you start with 3, then you are missing out on values in between 2 and 3. So like 2.1, 2.2, 2.5, all those values in between. So you always want to start with the number that is here. That's always included in your table. If it's not equal to, if it's just greater than or just less than, then you're going to use an open circle. And then let's choose 3 and 4. And then this is just, you plug in x here and y is the same. So those points come pretty quickly. Okay, so let's graph this. We're going to use some colors. Let's use blue for this, and then we'll use our green for this one. So just simply plot the points. So 2, negative 3, and that's a closed circle. And then all the other ones are also closed. So 1, negative 2, and then 0, 1. And this looks good because we know we have this parabola, and so we got this U-shaped thing. And then it will continue on this direction. So we kind of try to draw the curve in there. It's not a straight line. And notice that I'm not going past 2, because at 2 it changes. At 2, I'm at 2, 2 with an open circle. And then 3 and 4. And so this one is a line. And notice these points are closed. It's only the end point that's open. So the end point's open, but the rest of them are included. And then you can draw your line. So a couple things to watch for in terms of common errors. One is the open and closed circle, right? So make sure this is closed here because it's equal to, this one's open. Also, your function should pass the vertical line test. So you can't keep going with this line over this direction because then it would fail the vertical line test. Same thing here. If I continued on with my parabola and started going over here, then I would be overlapping and fail the vertical line test. There also shouldn't be a gap, or there probably won't be a gap anyway. There could be, but usually like this one stops right where this one picks up. So if you skip 2, you'll have a gap in between, and that's not likely with the problems usually people see from a worksheet or a textbook or whatever. Okay, and then domain. Domain, we're going to go left to right. So go left and then all the way right and look at all the possible values. So the smallest value is negative infinity, because this will just go forever. So it's going to go from negative infinity, and then it's going to continue to go all the x values, and this will go forever to the right to infinity. And then for range, our range, we go from bottom to top. So we go all the way down. What's the lowest we have? The lowest point is negative 3. And then this is going to go up forever. So is this one. So the highest point is infinity. Okay, so go ahead and pause the video and try this one, and then we'll graph it kind of quickly. So for that top piece, f of x is 4, and that starts at negative 2, and then it's everything less than negative 2. So I'm going to open circle there, and then negative 1 and 0, and it's always 4. So that table is fairly quick to fill in. For the middle piece, I'm going in between -2 and 1. So we're just going to fill all these values in. -2, -1, 0, and 1. So there's only 4 points there. We'll just go ahead and plot them all. And it's x squared, so just square it to get 4, 1, 0, and 1. And these are both equal, so this is going to be a closed circle and closed circle. And then for the third piece, f of x is equal to -x plus 6. X is greater than 1, so it's an open circle at 1, and then we'll just do 2 and 3. And it's a line. -1 plus 6 is 5. And then this would be 4 and 3. As you sketch your curve, make sure you think, well, this is a parabola or quadratic function, so it's going to be shape of a parabola, and the other two are lines. And then we'll use some different colors. We'll use blue for these two. So -2, 4, make sure that's an open circle, but the rest of them are closed. It's only the endpoint, and you can put as many points as you want there. It's just a horizontal line. Now this is interesting. At -2, 4, I have a closed circle where I had an open circle. So the closed circle wins. That means there's a closed circle there. And then plot the rest of the points, -1, 1, 0, 0, and 1, 1. And those are all closed. And then 1, 5 is another open circle. Oh, I forgot to connect those. So connect those. It's a parabola. So try to show that curve. 1, 5 is open, so we're passing the vertical line test still, and then it's going down with a slope of -1. And those points are closed. The domain, if I go left to right, it's going to go forever to the left, forever to the right. There's no x values that aren't defined, so domain is all real numbers. In range, it's going to go all the way down to -infinity for the lowest value. But the highest it gets is this point here, 5 with an open circle. So that's 5 with a parenthesis. Okay, pause and try this one. So there's just two functions here. 2x minus 2, that's when y is less than 1. So remember, you have to include 1 and put a little open circle there. And let's do some values less than 1, so 0 and -1. So at 1, we get 0 when you plug 1 in here. Actually, let's do it right here. When you plug in 0, you get -2. And when you plug in -1, you get, should be -4. Okay, and then the square root, that's a little bit tricky to plug in. Whoops, not 2x, square root of x. And so we have 1 and 4. Square root of 1 is 1, square root of 4 is 2. And we can find these other points here. Or you might remember that the square root curve just looks something like this, and you can sketch it in. So if you want to put 2 and 3 there, you might need a calculator to find the exact. There'll be decimals in between 1 and 2. But this is a closed circle here. And this is interesting. There's an open circle on the other end. Okay, so let's look at the graph. So -1, 0 has an open circle. And then 0, oops, sorry, that was the wrong point. 1, 0, positive 1, 0 has an open circle. 0, -2 would be closed. And then 1, -4 would be closed. And this is a line going this way. And just ignore this point here. I'm going to put some KU colors on that so you know it's bad. It was a mistake. And then we have our square root of x. The square root of 1 is 1, and that's a closed circle. And then we go over to 4, 2, and that's an open circle. And it's just a curve between the two. So the domain and range on this one. Domain is left to right. This line's going to go left forever. So it's negative infinity. But the furthest right we go is this 4 with an open circle. So we use a parenthesis. And then your range, the furthest down you go is negative infinity. And then range goes bottom to top. The furthest up you go is 2 with an open circle. So that's 2 with a parenthesis. Okay, and then I want you to go ahead and try this one on your own here. You want to write a piecewise function for the graph. Okay, so think about the pieces. There are 2 pieces. There's this line here and this line here. And I would just worry about the equation of the line first. So, and then we'll worry about the rule. So with this line, we'll call it blue. You could probably just count. You could see b is equal to 2. And then slope is up 1 over 1. So m is equal to 1. If you want to use the slope formula, you can, but you can just look at this and see that it has a slope of 1 from the graph. And so that gives us the function y equals mx plus b, or 1x plus 2. And that occurs when x is less than or equal to 1. So notice the x value, and I would even circle it or mark it somehow so you don't get confused with the y value. But when x is 1, that's when things are changing. And because this is a closed circle, it's less than or equal to and not just less than. Looking at this other line, if we can continue it, we could see that b is also 2. And now we're going down 1 over 1, so slope is negative 1. So that gives us negative x plus 2 when x is greater than 1. Notice it's open circle, and so that means it's greater than and not equal to. Good luck with piecewise functions, and reach out if you have any questions.